Okay, so now we're looking at 7.1, homework 22. And it's an initial value problem where they give you the second derivative and they give you information about the first and the original function. Okay, and so initial value problems are differential equations. So when you take the class differential equations, you're going to be scared and crying most of the time. But remember that Mrs. Brooks said all differential equations is getting back to the original function when you're given the derivative, even though it doesn't seem like that when you're in the class. Okay, so you have already experienced differential equations. You're going to experience one right now. All right, so homework 22 is the second derivative, they tell you, is 3 secant squared x. And they tell you that the first derivative at pi over 4 is equal to 0. And they tell you that the original function at 0 is equal to 0. So the goal here is to find y. You have the second derivative. You want to back up to the original equation. So to get dy dx, you will integrate the second derivative with respect to x. So you're going to integrate 3 secant squared x dx. And you're happy because secant squared x has an antiderivative. It is tangent x. So this is going to be 3 tan x plus c, right? Now, they give you information to find c. The information that they give you to find c is that this is y prime. And they tell you when x is pi over 4, so you could say this is like y prime of x. When x is pi over 4, you get 0. So y prime, when x is pi over 4, means 3 times the tangent of pi over 4 plus c is equal to 0, because that's what they're telling you. The tangent of pi over 4 is 1. And so c is equal to negative 3. Okay? So that tells us that the first derivative, dy dx, or y prime, is equal to 3 tangent x minus 3. So to find the original function, we will integrate dy dx. So y is the integral of dy dx with respect to x. So that's the integral of 3 tan x minus 3 dx. Ah, I see where you got stuck, probably. You may say to yourself, I don't know the derivative or the antiderivative of the tangent. Now, you may have just looked at that sheet. Do you remember that sheet that I gave you? Let's see. Integration sheet. Integration table. If you look at your integration table, it's actually on there. It is negative ln cosine u. I don't know if you can read that. Probably not. The antiderivative of the tangent is negative ln cosine. But just because we're in this section, I can actually prove that to you right now. So I'm going to derive that antiderivative for you with this problem. Okay, so the way that you get that is, first of all, is everybody okay if I factor 3 out of the whole thing? So I have tan x minus 1 dx. Just remember the 3's on both of those. Okay, now let's just deal with the tangent of x. So I'll do it in red. So let's consider the integral of tan x dx. Well, what you want to do is think of tangent as sine over cosine. And then you want your u substitution to be cosine x. then du is what? Negative sine x dx, right? Well, that's almost exactly what you need, right? You're just going to have a negative in front. So you're going to have the integral of sine x over cosine x dx is equal to the opposite of the integral of 1 over u du. And you know the integral of 1 over u du. It is ln absolute value of u. So this is negative ln absolute value of u plus c, or negative ln absolute value of cosine x plus c. Make sense? So that gets us to the antiderivative of the tangent back where we wanted to be. Okay, so coming back to the blue. It was 3 antiderivative tangent x minus 1. You now know that's going to be 3 times the antiderivative of the tangent, which is negative ln absolute value cosine x, minus the antiderivative of 1 is just x, and then plus c. And I guess if you want, you can distribute this 3 through. But you're not quite done, because you need to figure out that's y. But you were told that y at 0, which would be negative 3 ln cosine 0 minus 3 times 0 plus c is equal to 0, right? The cosine of 0 is 1, and the ln of 1 is 0. So this is 1, but then that'll be 0. So this is equal to 0 minus 0 plus c equals 0. So you actually discover that c equals 0. So your original function is negative 3 ln absolute value cosine x minus 3x. Okay? And so let's see if it likes my answer. Negative 3 ln absolute value cosine x minus 3x. I wonder if it's going to be ornery and like wish that negative 3 was factored out. What do you think? No, it was okay. You know what I mean? Like you could, okay. All right, does that feel okay? Do you think that was enough to get you the second one? Okay. Brandon, was that enough?